The next activity from our Forces, Matter, and Energy kit is conducting electricity. And for this one, students need to get our fancy conductivity testers. They've been put together and they've got these joints, but have students be very careful because these things can pull apart pretty easily. But these will be shared by pairs of students. You'll notice a battery harness. Students will have to attach a 9-volt battery included in the kit to the back of it. Now, one thing students will notice is that when you touch the two wires together, the light goes off. Do not do that. I know students are going to want to do that, but ask them to not do that. That's going to simply burn out the battery really quick. So what we're going to want to do is look at different things that we can put between the two wires and if it will conduct electricity. When you show this to the students, get a paper clip for a demonstration and have them take the two ends of the wire, touch either end of the paper clip, and if the light bulb goes on, the electricity is being conducted and going through. So we get out our magnetic test items, the ones we had before, and here we introduce two terms, insulator and conductor. What you just saw was an example of something that is a conductor. It allows the electricity to flow. The opposite of that is an insulator. An example of an insulator is going to be, let's just use the chipboard here, and once they attach or touch both wires to it, nothing's happening. So that's an example of an insulator, something where electricity is not able to flow. Take the conductivity, remove the conductivity testers from the students and ask them to look at each of the items and predict if they think it's going to be a conductor or an insulator. Have the students make their predictions and then hand out the items or the conductivity tester and have them test it. One interesting thing that happens, one of a few things, is as you remember with the magnets, only one of the three magnets or one of the three metals was magnetic. The one that had the iron, the brass, and the aluminum did not conduct. And if you notice with the conductivity tester, all of the metals conduct. So metal is a conductor, doesn't have the same stipulation or rules that the magnet has. One neat thing is the pipe cleaner. Students will notice that it looks like it could be an insulator, but also there's ways for you to, depending on how the student puts it together, there is a metal rod in the middle, and if they're able to touch that, it could be also considered a conductor. So that's one where students might have some debate on whether it's a conductor or an insulator. Okay, after this, students have a pretty good idea of what it means to be a conductor or an insulator. Last thing we give them is a piece of insulated copper wire. It's in the kit. And their challenge is to show you and provide evidence that this wire is a conductor and that it's also an insulator. And the way you do that is if they touch the bare wire, there's evidence that it conducts, and if they touch it to the rubber coating, then it doesn't conduct. You can explain to the students that in the houses, this is how the wiring is done. The place where it conducts is where the switches are, but all the things going on behind the scenes are all insulated, so that way you don't have fires and cause sparks. So when you are done with the activity, it's real important to ask students to take the batteries out of the conductivity testers, and when you ship them back, please make sure that they are separated. These things, if they stay in there, they can corrode and it would ruin the whole thing. So please make sure you disassemble them before sending them back. Thank you.